Hello everybody, welcome back to Named ACL. In this video, I'll be walking you through standard named ACL configuration. Access control lists are fundamental parts of network security. They serve as a tool to control traffic flow within a network, permitting or denying access based on defined rules. Access control list is of two types. We have standard access control list and extended access control list. Each of these two types is further divided into two. As you can see from this chart here, standard ACL is divided into numbered standard ACL and named standard ACL. On the other hand, extended ACL is further divided into numbered extended ACL and named extended ACL. In this video, we'll be focusing on named standard ACL. If you want to learn more about numbered standard ACL, numbered extended ACL, and named extended ACL, you can consider subscribing to this channel because in the next few days, I'll be uploading videos on those topics. Okay, let's now focus our attention on standard named ACL. There are different properties that is used to identify how you will configure standard named ACL. A few of them is listed here and I'm going to walk you through them one by one. Okay, let's begin with the first one. The first rule here says that standard ACL can filter traffic based on the source IP addresses. Okay, let me demonstrate with this network topology. If I'm trying to control PC2 from accessing this PC0, then my configuration is definitely going to be on this router 2. And this configuration is going to be based on source IP address, which is the IP address of PC2. So that is what they mean by the first rule. The second rule here states that named ACL can specify the protocol, example TCP, UDP, SMP that is allowed or denied for a particular rule. For example, if I'm controlling PC2's access to PC0, then my configuration is going to be on R2. And this configuration can be based on the type of communication, which could be UDP, TCP, or ICMP communication between PC2 and PC0. If a ping traffic which uses ICMP is originating from this PC2, then I can configure ACL on this router 2 in such a way that it allows only ICMP communication between PC2 and PC0 while denying TCP and UDP communication. Okay, that is what they mean by this second rule. So let's move to the next one. Okay, the next rule here states that standard ACL can define rules based on port numbers, allowing or blocking traffic on specific ports. Okay, let me demonstrate with this network topology. Communication between host devices occur in ports. Each PC has different port number. For instance, HTTP uses port 80. So if I'm trying to control PC2's access to PC0, then the ACL configuration on this router 2 can still be based on the port numbers. For instance, I can configure my ACL on this router in such a way that it allows only HTTP communication between PC2 and PC0. Okay, that is what they mean by this rule. So let's move to the next one. So the next rule here states that rules within a named ACL are processed in order. So the order of the rules matters. The first matching rule is applied and subsequent ones are ignored. For instance, if I have rule 1, rule 2, rule 3 configured on a router, then those rules are going to be accessed from top to bottom, and the first one that matches will be taken, while they will ignore the ones below. So let's move to the next one. The next one here says that each ACL is given a unique user-defined name. For instance, you can configure two different ACL in a particular router. In this case, if I configure two ACL on this router 2, then I need to give each of those ACL a unique name so that I'll be able to identify which ACL has which entries so that I can make changes to them whenever I want. So let's move to the last one, which states that named ACL can be applied to both incoming and outgoing traffic on a network interface. So let me demonstrate with this network topology. This router 2 has two interfaces, G01 and G02. So if I configured an ACL I need to apply it to either of this interface. Then once I apply it, I can also specify whether it's applied inbound or outbound. For instance, if I configured an ACL on this router and then apply it on this J01 interface, and then say that the rule should apply for any traffic going out of this interface, or it should apply for any traffic coming inside to this router through this interface. Okay, let's now open our packet tracer and look at the network topology that we are going to be making use of in this tutorial. So as you can see here, the network topology that we are going to be making use of in this tutorial comprises of two routers, router 1 and router 2. Each of these routers has two PCs attached to it through a switch. Before recording this video, I have already configured the IP addresses to the PC and to the router's interface. As you can see the network addresses specified within each of the interfaces of the router. And also you can be able to assign IP addresses to this PC using this .2.3.2.3 in this case. If you can't deduce the IP addresses to this PC based on this demonstration, then I'm going to show you the IP address table that I used to do this configuration, because I'm not going to go through that in this video, because if I do, it's going to make this video be too long. So here is the table of the IP addresses that I use for that network topology. You can take a screenshot of it, or if you are doing your configuration from your packet tracer, you'll be able to look at it and do your configuration properly. Also, before recording this video, I've also done the static route configuration. That is the configuration on this router so that PC existing on this network will be able to access PC existing on this other network. Static configuration is a topic of another video. If you don't know how to do that, you can consider subscribing, because in the next few days, I'm going to be uploading videos on static route configuration. Okay, so let's now go through the objective of this standard ACL configuration. Okay, the first objective of this tutorial is to configure a standard named ACL on router 1 to deny traffic coming from PC0 to the network 192.168.1.0 while permitting all other traffic. As you can see from here, this is PC0, while the network 192.168.1/24 is existing here. So one of the objectives of this tutorial is to configure ACL on this router 1 so that it denies all the traffic originating from PC0 to this network, which is 192.168.1.0/24. As you can see, this network has two PC, which is PC2 and PC3. And after this configuration, this PC0 won't be able to reach either of this PC, but this PC1 will be able to do. Okay, the second objective here states that we want to configure a standard named ACL on router 2 to deny traffic coming from PC2 to the network 192.168.3.0/24. As you can see here, the network 192.168.3.0/24 is existing here. So the second objective is to do the configuration in such a way that any traffic originating from PC2, which is this one right here, won't be able to reach any of these PCs existing on this network. So now that I have outlined the objective of this tutorial, let's now proceed to the configuration. Okay, let's start with the first objective. The first objective will say that we should configure ACL on router 1 in such a way that it will deny PC0 access to this network. So the first thing is to launch the router configuration interface. So you just double tap on it, then you type in enable configure terminal. Okay, you can configure ACL, standard named ACL, with the following command: IP access list standard. Then you need to give it a name. I'm going to give this a name called filtered underscore ACL. So once I click on enter, this command will create a standard named ACL called filter ACL on this interface. So after creating it, we need to give our rules. The first rule that I'm going to give is to deny access, PC0's access to this subnetwork. So what is the IP address of PC0? The IP address is 192.168.3.2. So let me enter it. Okay, let me deny 192.168.3.2. So we have denied PC0 access to that network. So the next thing is to permit every other traffic. So in that case, we are going to type permit any. So we are done with the standard ACL configuration. The next thing is to apply it to an interface. Let me reduce this so you'll be able to know what I'm trying to do. So I've configured this ACL on this router's on this R1. So the next thing is to apply it to this J01 interface so that it will deny any traffic coming from this PC0 from going out from this interface. So to do that, I need to exit from this mode, then enter into the interface mode, which is interface G0/0/1. So I'm now inside this interface. So the command to apply this ACL configuration to an interface is IP access group filter ACL. Then we need to apply it out. But in this case, I want to deny traffic going out of this interface. So that is why I put this out. So after entering it, you then click on enter, and then the next thing is to exit from this interface with this command exit. Then normally I save it with this command do right, so everything is okay. So the next thing now is to test it and know if our configuration is okay. So the objective was to deny PC0 access to all this PC in this network. So I'm going to enter PC0. So I go inside the command prompt, and I will now ping one of the IP address of those PC. So let me ping PC2. Ping 192.168.1.2. So it's not going to succeed. As you can see, it told us a destination host unreachable. Let me try it again. Hit enter. Destination host unreachable. If I also try to ping the second PC, which is PC3, it will not also work. As you can see, it's also telling us destination host unreachable. Okay, let me show you that I can ping from this PC1 to the PCs in those networks. So let me close this one and then enter the command prompt of PC1. Okay, let's start by pinging PC2. So ping the IP address of PC2 is 192.168.1.2. So the ping is succeeding. As you can see, I got a reply. So let me ping PC3, which is on the same network. So as you can see, it is also reply. So now that we have configured the ACL that deny access of PC0 to this network, let's move on to next objective, which is to ping to configure a standard ACL on router 2 to deny traffic coming from PC2 to the network. So to configure ACL on router 2 to deny traffic coming from PC2. So let's go back to our packet tracer. This is router 2, and we are trying to deny traffic coming from this PC2 to this network. So we enter the configuration interface. So enable configure terminal. So the first thing to do is to enter the ACL command. In this case, is the IP access, list, then standard Then we need to give this ACL a name. In this case, I'm going to give it filter underscore ACL2. So I click on enter. After that, I need to give it rules. The rules I'm going to give it is to deny PC2 access to that interface. So to do that, I just need to type deny. Then what is the IP address of PC2 is 192.168.1.2. So I will deny this IP address and then permit in. So the next thing is to apply this ACL into an interface. So let me move away from this mode, exit. Sorry, I made a mistake. Exit. Then I need to enter the interface of which I want to apply this ACL to. In this case, I want to apply it to this G0/0/1 interface. So I need to type interface G0/0/1. I've entered the interface. Then after that, I need to write that command IP access group. Then what is the name of the ACL again? Is filter underscore ACL2. Then it also needs to be applied out of in interface. So after that, I need to exist, then do right. So now we have finished the second objective. The next thing is to confirm whether we achieved our goal, which is denying PC2 access to all the PCs in this network. So let me enter this PC and then go to command prompt. From here now, I will try to ping either of these two PC. Okay, let me try PC0. So ping 192.168.3.2 is not going to reach. So we are seeing destination host unreachable. Okay, let me try the second PC. Ping 19. Okay, let me just use this up arrow. Dot 3. Also, destination host unreachable. So let's go to the second PC and confirm that we'll be able to reach this network from the PC. So let me open the command line interface of PC3. So from here, I will now ping 192.168.3.2. App including the app table. Let's give it small minutes. Okay, remember that in first configuration, we said that PC0 should not be able to reach PC3. So after I do this ping, the packet will be sent to this first PC. Then this second PC will need to apply it. But because in the first objective, we configure this in such a way that PC0 can't reach any of this network. That is why it's saying timed out. Let us go to the simulation mode and repeat the ping message again. So PC3, up arrow, click on enter. Let's now view it using this simulation. As you can see, it has sent the packet. Now the packet is going to get to this PC0, but because the first ACL configuration on this router say that this PC should not be able to access any of these PC in this network, then when it wants to reply PC3, this configuration here will block the packet, thereby resulting to that timeout. So you are going to see it right away. Let's give it a time. Let's give it a time. Now is at router 1. As you can see, the packet can't pass here because of that first objective configuration that PC0 should not be able to reach PCs in this network. So the next thing is to try pinging from PC2 or from PC3 to PC1. Is it going to work? Yeah, it should work. Let's ping from PC3 to PC1. Let me close. Okay, let's ping PC1 again. ping 192.168.3.3. As you can see, we are reaching it. So as you can see, our ACL configuration is done properly. And if we should view this in simulation mode, I think we will have a better view of how the packet moves. So I'll come back and show you how the movement of the packet is. So let's give it a time. I'm going to fast forward this. I'm going to fast forward it. So we have successfully reached PC1 and gotten a reply. And that's it for this video, guys. If you like this, please give it a like. Also, if you have not subscribed to this channel, please do that by using that subscribe button below and turning on notifications so that you'll be updated once I release new video.